Look at a modern web interface. We experience the web visually through frosted glass, soft shadows, and crisp typography. But this aesthetic polish relies entirely on an invisible structural foundation. Beneath the surface, every web page is organized into a document tree. The document tree is the hierarchical structure of nested HTML elements that browsers use to map and render content. For years, developers built these structures using something colloquially called div soup. A div is a generic container element. Relying on them for every part of a layout creates a chaotic stack of meaningless boxes. To a human looking at a screen, a stack of heavily styled div tags looks perfectly correct. But to a machine trying to parse the page, those generic tags offer zero context about what the content actually is. To bridge the disconnect between human design and machine readability, we have to write code using the web's native building blocks, Semantic HTML. Every standard HTML element consists of three core parts: an opening tag, the text content it wraps, and a closing tag. While tags define the base structure, attributes are injected directly into the opening tag to provide configuration and unique identifiers to the element. Two of the most common global attributes are ID and class. An ID assigns a unique identifier to a single specific element on the page, while a class groups multiple different elements together so they can share the exact same styling rules. In early web development, tags like font or center were used to handle presentation directly in the HTML. Those are now completely deprecated. Visual styling is strictly separated into CSS, leaving HTML to handle pure structure. Mastering this basic syntax is the strict prerequisite for upgrading a generic, meaningless wireframe into a deliberate architectural structure. This presentation slide outlines the definition of semantic HTML. Instead of relying on non-semantic tags like div and span, semantic HTML uses meaningful tags like header, article, and footer that accurately describe the specific purpose of the content they enclose. This code snippet shows major structural elements. At the top, a header tag encapsulates introductory content, with a nested nav tag defining navigation links. Moving down, the main element acts as the dominant container, isolating the core subject from repeating sidebars. This comparison slide shows how we handle specific types of content. On the top, the article tag wraps independent, self-contained content, like a blog post. Below it, the aside tag holds secondary, loosely related content, such as a list of related links. This snippet shows the bottom of the document tree. The footer element closes out the page, containing contact information, copyright notices, and closing metadata. This side-by-side practical example visualizes a final assembly. All these individual semantic elements stack together to form a complete, unified page layout. Using semantic HTML shifts a developer's mindset. You stop simply placing boxes on a screen and start accurately describing the data's informational hierarchy. When a fully semantic codebase compiles, it directly powers the final, polished user interface that we interact with. This structure provides three distinct benefits, starting with accessibility. Screen readers, assistive software programs that read on-screen text aloud, rely entirely on semantic landmarks like nav and main to help visually impaired users navigate the page. The second benefit is search engine optimization. Search engine crawlers, automated bots that index the web, prioritize structured content. They use strict heading hierarchies from H1 down to H6 to determine exactly what a page is about. This slide outlines the key benefits, adding maintainability alongside accessibility and SEO. Clear, descriptive tags reduce code complexity, making it significantly easier for future engineering teams to collaborate and update the codebase. Semantic HTML is a practical mechanism. It is the code that guarantees a website's usability, its visibility in search results, and its longevity in production. Writing strict semantic HTML separates amateur web layouts from professional software engineering. It acts as a universal translator, bridging the gap between human-centered visual design and machine-readable reality. We spend our time admiring the interface, but the highest quality engineering on a website is the invisible structure holding it together.